All right, my name is Rob Hinst. I am a senior manager of software engineering at Crown Castle. I don't have display. That's me. Okay, do over. I'm Rob Hinst. I'm a senior manager of software engineering at Crown Castle. I want to talk to you a little bit today about our journey with NSO and specifically tips we've learned about reconciling services on a brownfield network. So if you're not familiar with Crown Castle, we are a provider of shared communications infrastructure. So for us, that means towers, fiber, and small cell. And I've been using NSO for a while now, maybe not that long, but back in 2014, our fiber business was growing fast, and we were looking for a smarter way to scale. So my VP of engineering set up a meeting with a company called TailF, who had a product called NCS that promised model-based network orchestration. And we sat down with them, we talked a lot. I hadn't seen a product like this before. We really liked it. I got some time, hands-on time to play with it. And in late 2015, we made a purchase. I think that was shortly after Cisco had acquired TailF and renamed NCS to NSO and bumped the version of 4 and all that stuff. And at the time, our network automation team was just me stuffed in a corner of our network planning organization. I had arrived via an acquisition of an acquisition of an acquisition, and I think they didn't really know what to do with me. I had a network architect title, but my background was software development, and I had like just enough networking knowledge to be dangerous. So naturally, they did what you do, right? They gave me the keys to the network and this product that could swiftly and elegantly tear the whole thing down in a few minutes if I wasn't careful enough. Luckily, it worked out for both of us. Fast forward 10 years, I have yet to do anything truly disastrous on the network. And they've even given me a team of like-minded misfits to keep me company. There's 6 of us now. We are responsible for network automation, among many other things, at the fiber business unit of Crown Castle. Oh, that was an accident. And we've learned a lot over this time. NSO is kind of only a smallish piece of what we do, but we've learned a lot. And despite always having an itch to go just a little bit faster, I'm proud of what we've done. And NSO has been central to all of our successes in network automation. The initial use case that I was given was to automate the provisioning of a subset of our customer Ethernet services. Like I said, I like to go fast, but I also want to keep things simple as much as possible. And above all, for this, I really wanted to prove out the effectiveness of NSO on a network. So I built out what I would call a compact, opinionated model. When I say opinionated, I mean our network design standards were largely hard-coded into the templates. And compact meaning I kind of minimized the amount of leafs we had. I only wanted leafs to control the things that were supposed to change based on our network design. And I reused those leaf values throughout the templates in different spots. So it felt great when we first rolled it out. We drastically reduced provisioning time on these services. And above all, we proved out the usefulness of NSO on the network. Now, that initial model was never intended to satisfy every future use case, but it did exactly what it needed to do. And it's formed the foundation of all the automation we've done since. So my first piece of advice to you guys is, especially if you're just starting out, do something. Pick something manageably small and automate it. It could be a BGP session. It could be a static route, a police or policy, something that's going to be useful to your organization that you understand well enough to get your head around and automate. And by all means, spend time planning. Talk to your team, talk to your managers, talk to your peers in the community, figure out best practices, have a design, figure out what your risks are going to be for that service, and mitigate them to the best of your ability. But then get your hands on a keyboard and make something. The actual built product, once you've got it in production, will always give you more and more reliable information than anything you can imagine in your head while you're planning out ahead of time. So just do something small and get it out there and start that feedback loop. And then sort of the second part of that same tip is just accept it's not going to be perfect. So anytime you go into a situation trying to solve for a problem that you don't have perfect information of, in other words, always for the rest of your life, chances are, oh, yeah, I'm on the right side. Chances are you're not going to build a perfect solution to that problem. And that's okay, that's cool, don't fret. Unless you like brick 100 routers and then go have yourself a panic attack and then come back. But like, otherwise, just be happy that you've got something out there and now you're learning about what the next thing to do is. So in our case, the imperfections in our first iteration were not so dramatic as taking down a bunch of routers. We just had some sync issues. Mostly due to out-of-band change on the network. We have a very brownfield network. So our models worked great for pumping out services configured according to our current design standards. But over time, as we moved on to other projects and did other things, we started to notice that services were drifting out of sync. And if you've used NSO for a little bit, you know that that's kind of a showstopper, right? Like once your service is out of sync, it makes it really hard to then do day 2 type workflows. Changes, disconnects, migrations, that kind of stuff. So we needed a way to reconcile our services. And I want to take a second here to define what I'm talking about. And it varies a little bit from what I would call service discovery, although a lot of the methods are the same. When I say service reconciliation in the context of this talk, what I'm going to mean is some sort of application reconciliation engine is thrown around a little bit, but some sort of programmatic method for taking an out-of-sync service and some network data, preferably actual config, and combining them in such a way that you're correcting the out-of-sync services, service parameters, in such a way that at the end you have an in-sync service. By the way, this is how you know I didn't use AI to generate my slides, this artisanally crafted PowerPoint slide. Pretty proud of this one. Okay, so as we set about trying to figure out how we wanted to reconcile our services, I came upon a really good blog article on the NSO Developer Hub by a now former Cisco employee named Dan Sullivan, who love me some Dan Sullivan. If you know Dan, shout out to Dan. But he proposed a template-based method of service reconciliation. And what I liked about it is it used the same methods that we already had learned for service creation with a template-based package to do reconciliation. So whereas with service creation, you're taking service parameters, pumping those through a template that maps them onto leafs in the device branch, this would take leafs in the device branch, pump them through an XML template, and map them to service parameters in your service instance. And hopefully, in the end, your service would be in sync. So like I said, we liked this because it used techniques that we had gotten good at when we were building template-based packages. So we took that, we did our first iteration of that, and we built a service audit script that would run nightly, and it would check sync on all of our CFS services, and for any that were out of sync, it would run this reconcile action. We had implemented it as an NSO action on each service. And like I said, so we did something small, we iterated, it was imperfect. Spoiler alert, iterations 2, 3, and 10 of service reconciliation were imperfect for us as well. So another thing that our service audit script did was collect data for us to make better future decisions on how to improve our reconciles. So what we did was anytime a service failed to reconcile, we would capture a redeploy dry run output. We would split out all the lines. We would strip out all the keys from those reconstructed key paths, and we would get what you call tag paths in NSO, and we would chuck those all in a database and then count them up on a dashboard. And what that told us was where our services tended to be most out of sync in ways that we had yet to figure out how to reconcile. And then that in turn would tell us where we can have the most impact improving our reconcile logic. So tip number 2, I highly recommend maybe it doesn't take this form, but collect data, make data-driven decisions on how to improve what you're doing now. And at the same time that we were working on this reconcile logic, we realized we needed to extend our models as well. So using the same exact example you just used. So our original templates looked like this on the left here. So we were hard coding the design. The design said the MTU should be 1500. We were told by the other architects that's what it should be. I'm sure that's what it's going to be all over the network, right? But then as we discovered more kind of variation on the network from that, we had to create what we call override leafs. And this is the same kind of thing that Huda has just was talking about. We wanted to preserve the default behavior dictated by the design. But when we found a value on the network that differed from that, we wanted the ability to, we needed a leaf to stick it in, first of all, and then a way, logic, to override that default value. So we started adding complexity to our templates in this form. This kind of blew out our models a little bit. It increased the verbosity. We have more leaves now. But the trade-off is that, it increased the flexibility of those models to represent the reality that we find on the network. So we continued for a little bit with that pattern, iterating. We would do something. We'd learn something from it. We'd do the next thing. And we did that for a few years. And our sync rate steadily improved. We got better at reconciling services. And we started, over time, to gain more of an ability to process day 2 type activities. We're now doing more changes, more disconnects, more different workflows through NSO, rather than just pushing services out to the network and hoping that they did something. So iteration is great. I super recommend that. Get started doing something small, iterating on it. But at some point, we realized that we had an opportunity to maybe step back, zoom out a little bit, and consider a refactor. And for a couple of reasons. One was all of that complexity we started to add to our templates. We started to realize those templates are working maybe a little bit too hard and had a lot of complexity and logic, business logic in them that maybe should have been pushed up higher in the stack. And this is going to be maybe specific to my team because we like doing stuff in Python. My team, those guys in that photo, are mostly expert Python programmers with a little bit of networking knowledge like I was. And I realize that's maybe the opposite of a lot of people here. But so we wanted to move that up, right? And we also, with the reconcile logic, that initial template-based approach was great to start, and it got us a fast start. But we also, over time, as that became more complex, realized my slides are just changing on their own here. That we wanted to do that differently also. We realized there were also some inherent limitations that I'm going to cover in the second part of this presentation in the way we were doing reconcile. And so we're doing kind of a full refactor right now on our service models and our service discovery methods. So just some quick to explain kind of what we're doing now. We're now starting to build flexible, unopinionated models. So lots of leaves to describe what we might find on the network. And the business logic has moved higher up. So we actually, like I said, we're Python developers mostly. We have a robust set of Python microservices that live northbound of NSO. And that's where we would rather organize our code. We've got great tooling up there. We've got unit testing down. It's much faster than spinning up an NSO instance to test your models. So if you can move most of the logic up, then when you make a change, you're mostly doing it in a spot where you can run some fast unit tests and be done with it, And we're also rewriting, I mentioned, service reconciliation as a new standalone Python application. It does a bunch of XPath queries to find the information it needs and pushes it back to the services. So this is tailored, like I said, to my team strengths. This might not reflect your team strengths. Only you know what's best for your specific situation. Hopefully, some of the stuff I'm about to cover here in this next part will be applicable to some of you. All right, so this is what I consider the good part, because you can tell because there's going to be stuff in like monotype fonts. So I kind of already did the disclaimer, but depending on how you model your services, depending on how what your composition of your team is, what your organization looks like and your business processes and things, some of this may be more or less applicable to you. I just hope that some people in here have something they can take back to their network and use. All right, so straight into the technical details here. So this is some things I'm going to go into now that we learned that helped us make more reconcilable services. And as we refactor what we're doing now, we're kind of using these principles. So one of them is avoid reusing leaf values. So let's say you have a circuit ID leaf in your service, and you know that by your network design standards, your police or policy should be named after that circuit ID, and your BGP import policy should be named after that, and your port description should have that circuit ID. It feels nice and thrifty to just reuse it everywhere, right? And that works fine as long as they're all the same. Even if they all change and diverge from what that is, at least you can reconcile them back in as long as they all change. But the second that less than 100% of them change, congratulations, your service is now out of sync and unreconcilable. So the way we're going about to solve this is just making more leaves. And So I recognize that you can go overboard with, just like anything, you can go overboard with creating leaves, right? But the more you have like a one-to-one relationship between your service parameters and the stuff they end up setting on the network, the more flexibility you have to be able to map them backwards. So if services going out of sync is a big problem on your network, if this is prevalent for you and you find that the things that are supposed to be a certain value are not, this gives you the most flexibility in controlling them. So you need to find that balance between not having crazy looking service models and making them more flexible and reconcilable. Tip number 4, and this applies specifically to stacked services, which we have. And this is going to require a little bit of explaining too, is reconcile your CFS directly. So like I mentioned before, you can look at reconcile sort of like create in reverse. It's taking the stuff you put here, seeing how it's changed, and putting it back here. But how does that apply to stacked services? So when we sat down to look at it, I was like, well, it's still create in reverse, right? When you create with stacked services, it's a two-stage approach where you fast map service parameters from your CFS to your RFS, and then you do the same thing from your RFS to the device branch. So let's build some reconcile routines from device branch up to the RFSs, and then a second stage of reconcile that kind of puts it all back together in the CFS. It seemed like a good idea at the time. And the reason why I wouldn't recommend it is, and don't get me wrong, like we're still using this right now. We're in the process of rewriting this, but it's gotten us this far. It wasn't terrible, but if I had to do it over again, I wouldn't do it this way, and we're not doing it this way in our rewrite. And like I said, the reason is not because it's 2 stages. It has to do with something that I'm going to call anchor points. So when you reconcile a service, let's say you have a port on a device that you know is a part of your service. So what you want to do as much as possible is make inferences based on your network config. So if you know the way on your platform a port gets assigned as a member of a VLAN, you can use that knowledge in your service discovery to say, well, I see that this port's part of this VLAN, now I'm pulling that VLAN into my service. And there's an IP address configured on that port, so that's part of my service. And I see there's a BGP session whose remote neighbor is an IP address in the same range as this IP address. According to my network design and my knowledge of the network, I'm going to write in logic that pulls that in. That's part of my service now, too. But how did you know that original port was part of your service? You have to make an initial assumption and then kind of branch out your discovery logic from there. And it's actually really hard to do, depending on how much your network changes out of band. Right? So like you might say the physical port's a good place to start because your service is not going to physically jump over to another port that often. But if a customer upgrades and needs a higher capacity port and somebody makes that change out of band, your physical port assumption is wrong. Or if it's an IP address, they needed to upgrade to a larger range of IPs, and you sent them back to your IPAM, and they got reassigned to another customer, and now you just discovered the wrong service under this service, right? And port description's a popular one, too, because it's standard practice in a lot of places to use a service identifier in a port description, so you can just look for the circuit ID you're looking for and say, that's true, right? That matches. But the thing about a port description is it's just free entry, so it can be typoed, it can be on the wrong port, the port next to the one, so, or it was on here and then it never got cleaned up, right? And it's not going to affect, probably, your service. It's not going to cause a service outage. So it can go undetected, it can be wrong for a long time and nobody's going to know, and it just, you know, it's not necessarily the most reliable place to start. I don't have a good tip for you to say, this doesn't end in me being like, use this as your anchor point and use this as a method. Maybe you use multiple of them and correlate them together to figure out this one is more probably correct or whatever. But it's a hard problem to solve, and it's compounded when you try to reconcile your RFSs first. And the reason why is because, so one of the things that I thought would be a benefit of this was when you reconcile your RFSs first, I'm like, okay, cool, we're doing smaller, more manageable reconcile logic each time, and then we're kind of just combining them up. But the flip side to that is each RFS, well, let me start with the CFS. With the CFS, you have all of the service parameters that describe your service. Obviously, some of them are wrong because you're out of sync, but you have at least all of those data points to go on, and you can pick from all of those to use your anchor point to discover from. Each RFS has a limited window of those leafs that it knows about, right? And so it inherently has like fewer things that it can kind of latch onto as an anchor point to try to discover the rest of that service. And they might all be wrong. And so you're now making for each RFS you're increasing the number of assumptions you're making and doing your reconcile, at least one per RFS, and you have less data to go on to try to pick a good anchor point. So if you are trying to reconcile stacked services, I would recommend, even though it seems simpler to just kind of reverse out the create logic and do it that way, create new logic, to just feed stuff in the top. So you want to map device data directly into your CFS, and then if your templates are correct and everything's built correctly and you do your reconcile correctly, your RFS service parameters are going to end up correct anyway, and the service is going to end up in sync anyway. You don't have to bother with 2 stages. All right, I don't know if this is going to be controversial or not. So I mentioned you want to discover as much as possible directly from network configuration. But there's some stuff that you just can't, or it's difficult to. So a common one is topology data. If you have 2, especially like layer 2 devices that are physically connected, that's not usually represented in config that this port on this device is connected to this port on this device. So what do you do then in that case? And there's a couple of options. One is you can use operational data and say, maybe I have CDP or LLDP configured, or I want to use Mac Learning or whatever. I want to look at that information to determine what port is connected to what port, and then use that to make that inference for my service reconciliation routines. The downside of that is performance penalties if you're running out and making show commands in the middle of reconcile in real time. That's going to slow down your reconcile. May matter, may not. If you only have a few services out of sync, maybe you can afford to do that each night. The information is probably going to be correct, so that's the upside. Or you can go out to an inventory database and pull in information from topology or whatever it is from there, either reaching out in real time, or you can, what we've decided to do is just ETL certain topology into CDB, so it's a lot easier and faster to access. And the downside of that is the data quality is only as good as the data quality, right? If your records are good, then it's good, and if they're not, then it's not. But at the end of the day, if it gets your services more in sync than they were, then maybe that helps you. For lack of a pithier title, I'm calling this one "Let Things Be What They Are," tip number 6. So when I first started out with NSO, I wanted to abstract the hell out of things, right? Like I was like, we want intent in our CFS services, just like RESPnet, right? You want intent at the top and then translate it to network config down at the bottom. And that actually may be where I end up, but I don't think I was ready for it when we first started modeling. Because what happens is you can too easily set yourself up to create unreversible mappings. You need to figure out how to define intent in reverse from network configs then. And that's not always easy. And I'm going to skip all this stuff and go right to an example because I think it's the best way to illustrate it. So you may create a leaf. So your network architects may say, when you're configuring an uplink port, you should set these settings. And that in your design documentation might be how it laid out. So you might say, I'm going to create a leaf then. That's a Boolean leaf. If it's an uplink port, do these things. If not, don't. So if you model your stuff that way, and then set port mode to tagged and description to whatever, and set enable true based on the is uplink port leaf, it'll work great for creates. But then you just need to be careful. And it's not inherently bad, but when this goes out of sync, when this service, right, this larger service that contains more than this config goes out of sync, and you're trying to rediscover all of the service parameter values, is it safe to say on your network that every port you come upon that's tagged with this description, with this setting, is necessarily an uplink port? Because if that's not a one-to-one mapping, you might then incorrectly set things to is uplink port true. And that's kind of there's worse examples that we've come upon. But you just have to be careful about the assumptions you're making and how difficult it's going to be to map that back to intent. If, on the other hand, your leafs are named more directly after configuration type directives, they're a lot easier to then reconcile back from the network, right? If I want to figure out what the correct value of this for my model is, you look at the port mode and you put it back in your port mode leaf. It makes it all a lot simpler. Okay. So there's a lot more that I could share with you. There's plenty more mistakes we've made. There's cool tips and tricks that we've learned also that kind of weren't relevant for this presentation, but maybe we can talk after. And look, I don't have any illusions that what I'm showing you here is like the right way to do things or the right way to do things for your network. And even I might look back at this presentation in a year or 2 or 3 and be like, shit, I told him to do this, but looking back at it now, I would have told him to do this, right? And if so, I apologize. But like I kind of also feel like if you don't look back 3 years from now at what you're doing now and say, man, I wish I would have done that differently, then you're like not learning or growing, right? Like that's kind of one of the things that I like about the job is figuring out better ways to do things every year and seeing new things come out, like the reference architecture type stuff, and seeing what I can learn from that. And I'm sure there's people here today that have probably been doing this for a while that have service sync issues, that have had to work on the problem of reconciliation, or maybe you come at it from, I think Telecom Serbia was doing more what I call service discovery every night, right? That's kind of a more agnostic way to do it. That's not centered on a specific service, but like maybe you guys have tips for things you've done, approaches that you've had, things that worked for you, tips that maybe could have been up on this slide. And I would love to talk to you guys either afterwards, out there. Feel free to email me, get in touch, and let's keep the conversation going. And I've got a bunch of time left on the clock, so if you guys have any questions at all about service reconciliation, about what we're doing at Crown Castle, about what beard dye I use, please. And thanks for being here to listen to me for a little bit.
So, do I get it right? In some way, you were doing something with NSO, and then you actually redid everything. I'm at the stage where I'm also thinking if I would have done my service differently 1 year ago, but now I'm scared to change something because it's already in production. How awful is it when you rethink things?
So it's time consuming. It's fun to go back and rewrite something from scratch. It's a lot more fun than having to kind of muddle through the bad decisions you've made in the past and tack things onto it, right? But there's pain associated with it, right? Anytime you do a refactor, especially going back to the start and starting over again from a blank file, right? We're completely rewriting some of our service models, and we're completely rewriting our service reconciliation application. So it's going to be time consuming. We're in the middle of it now, so I don't have like a good slide at the end to be like, we got to 100%, you know? But yeah, just like anything else, it's effort. And you just need to have a good strategy for doing it. It's really going to be dependent on what your network looks like and what your processes look like. Like, can you kind of stand up a new instance and discover all the same services into your new service model and just have two running at the same time, and then at some point this goes away? You know, that's really highly dependent on your environment.
Hi, Rob.
Hey.
So what are the business outcomes that you're looking to achieve with this? And how did you manage to convince your management to do this change? Because I think there's a risk associated with it.
So we have a decent amount of autonomy when it comes to network automation, and part of the reason it's a good thing and a bad thing. So one of it is there's still a lot of teams that are not using automation, especially through NSO, to make their change on the network within our organization. In fact, mostly we serve our provisioning organization as they pump out new circuits. But we're just now starting to do more stuff with network engineering around infrastructure and things like that. So we kind of like are in this little vacuum where like us in provisioning, they tell us what they need. We've been building onto it for years, and we kind of have the power to like make those decisions, even if we want to remodel or do whatever. If we had more buy-in from more groups and they were all tied into this stuff, then it would make it a lot more complicated. Like you said, we would need to then talk to teams because maybe this changes their workflow or their business process or whatever. So it's kind of up and down in that sense. I hope that answers the question.
We have one question on Slido.
Does it help if I read this out loud for the recording? You mentioned having a northbound Python system that calls NSO. Are your CFS services defined in NSO or in that northbound system? So our CFS services are modeled in NSO. So they're Ethernet and IP services modeled as services in NSO that then our RFSs are modeled under those.
Do we have any other questions? Yeah.
Can you go into a bit more detail about what the Python microservice layer then does, maybe?
It does a lot. So, like I said, network automation, like changing configuration on device on the network, is a part of what we do. But there's a lot of kind of automation or programming kind of things that we just do also, where we're automating stuff in our inventory databases and all kind of stuff. Probably a lot of you guys do, you know, a lot of the same things. You can program some, so people want you to do everything, make everything faster and easier that they don't feel like doing. So like, there's a lot of projects that we do for automating things in our inventory system. So our microservices cover, we try to front end all of those systems with our microservices. They're Python gRPC based microservices. They do, you know, CRUD operations on our inventory database and our BSS, our OSS, down to NSO, like anything we can think of that we want to automate to. We start from the angle of like, okay, how can we front end this with a microservice? Because we also have people in our network engineering organization. We're starting to have people who can do some Python, and we want them to kind of use all of this one interface for interacting with things that happen on the network and in our different systems.
All right. Do we have any other questions? Okay, thank you very much.
All right, thanks, guys.